Hello, this is Joe, your chief geek from Ancient Text Research. I want to walk you through this two-part tutorial that explains how to search names within ancient texts and how to determine if they're statistically relevant. Now I know, based on comments we've been getting from videos, that I'm addressing two camps of thought here. There are those who want to refute the findings in the Chamberlain Key, and that's okay. That's actually how STAR came to be, is to actually be the naysayer and to figure out what was going on with these very strange results and whether or not the author was playing parlor tricks. Then I know there's those who are actually doing research into their own findings. They're actually looking at their names, and we've done special videos for certain persons who are doing that to find if there's relevance to their name and what else they find in the matrix, etc. We will continue to stay in the middle and referee. That's the whole point of STAR. We've built what we consider open and powerful statistics to allow you to determine the relevance of your own findings. And by open, you can inspect the code, you can inspect how the numbers are developed to determine whether or not something is really just there by random happenstance or truly relevant. It really pops out. We want to represent the voice of logic and reason. We want to prevent you from falling into the trap of parlor tricks by others, and also for those doing their own searching, that you don't trick yourself. Now there's some calculations you're going to have to do on your own. If you have biological data that enters into this, we don't factor that in, and so you're going to have to, you can look how we do our calculations, but you'll have to add that in to determine the total overall probability of some particular finding. So I have the user manual shown here because I want to take you through what we call the Travis test. It's a very good sanity check on what's going on here with names and other findings, and it's clearly outlined in the user manual, and it shows one, how you can translate a name and look at the statistics and whether or not you will actually find real relevant findings for such a name as Travis. Of course, there's some relation to that name. I won't go into those personal details. But so this is what we're walking through. All right. I'm going to move the manual, but you can always follow along in the manual. And that was section. I think we're up here in the potpourri. I'm sorry, potpourri section. I think it's 4.6. Okay, so let's actually show you a couple ways to develop a name, to find a name. One is to simply put your name in the English field, because we're searching the Hebrew ancient text here, and we're going to need to translate. So throw Travis in there, and we just reached out to Google, did a translation. If you do not get a relevant translation here, you may just have to go to your browser and bring up Google Translation. And that did happen to a particular user. He went to the browser, to the Google Translate page, and got his own translation. And that was taken care of. So another way you can do this is go right to the names and search. Now in this case, we have Travis in here. You can go into the quick search field, and there it is. Okay, and in some cases we have the name and the translation immediately available. Its origin, of course, Travis is a masculine, good-looking guy from the word traverser. You can read all about that. Now, from here, if you hadn't already copied the Hebrew translation, you can just hit search, and it will put, there's a quick way to quickly put the Hebrew into this primary search field. There's other ways to do it, and you can use this tool here to copy terms to other search fields. Okay, you can put in any of the secondary terms if you were searching in a matrix, or right to your own database. So that's a couple little features there. I primarily want to look at the statistics of this, okay, because I know a lot of people are beginning to use the tool for that purpose. So, before you search, you may want to run some quick statistics on this. Now, if you were only going to search one particular distance, you would indicate that here. This is kind of an a priori type of thing that oh, it's got to be at length, maybe it's length 32 to 32, and you're only going to search under the algorithms here going vertical and reverse vertical. For both directions, you're going to search at this length. Okay? What's the likelihood? Statistics. Sorry about the screen. There we go. Let's not be in research mode. Recalculate to give you a quick look. Sorry about, again, the screen. This video capture tool really fouls things up. Okay. So, 2 attempts for that name Travis. Wow. 1 in about a 2,048 chance. And this was expected in 2 search attempts. It figured out the number of attempts because you said you're only doing it at one length, but you're looking at it forward vertical and reverse vertical. Let's make this more interesting. What would we see? And I know people are going to do this. They're going to want to look over many lengths, all the way to 10,000. Now, what are the statistics on that? Very probable. Okay. We would expect to find the name Travis here in the text, just based on independent random pulls of letters out of this letter sequence, about 5 times. You can hit research mode and it shows you how we build to that number. And we look at the probability of each letter. And of course the first letter we know is a tet. And it's guaranteed you're going to find it by searching 20,000 times. It's essentially you've jumbled in each test case. Each search is a test case where if you treat it as a random sequence of letters, you've jumbled all these letters, thrown them in a barrel, and you're picking one at a time. If you were to make this one attempt and recalculate this in search mode, okay, you can see that you would find, just as of the first letter, 6,275 occurrences. Now, why is that? Because if you look at the character statistics of these letters, we know the tet. Sorry again, this screen. The tet here shows up about 0.53% of the time. There are 6,275 tets from this particular range of letters here, the whole Hebrew Bible. Okay? So, that is why we expect you to find all 6,275 characters. Each additional character provides its own probability, so you have to find the first one, then you're going to pull out another letter at this sequence, and its probability of that individual letter is 5.6%. Multiplying that next independent event gives you a cumulative probability of this, 5.6%, because the first event is pulling the tet out, and it's a 100% chance. Then you have to pull out the resh, because that's the second letter of this Hebrew name Travis. All these things have to line up perfectly, and so you get this cumulative probability that decreases over time based on each letter and the individual probability of each letter. And this is my point about showing the openness of the statistics. We're telling you exactly how we figure it out. Okay? And for those who are hackers, you can actually go get the source code. So, this particular case, let me move this again so I can, in one attempt, is not very likely. But if we're going to do it 20,000 times, it's very likely. In fact, we think we're going to get 5. So let's actually see. Let's see if our math predicts what we will see as a result. Okay, and I'm sorry, this is a little long sequence. You can see it searching. We're doing a vertical search here to start, and it's going through each length as we search. Okay, it's a vertical algorithm first, and we're going to go each EDLS skip all the way 1 through 10,000, and then after it completes that sequence, it's going to do a reverse. So as you can see, we're 30% through. You get this little status here as to what's going on. And we've already found 2 results. Now, I just noticed that I'm actually not searching the received text. Okay? I am in the randomized Leningrad Codex. So this truly is a random letter sequence made up of the primary distribution of letters in the Leningrad Codex. We've just scrambled them so that it's a sanity check, and it also checks that our math is consistent with what we have modeled as random letters, and our probability treating these as independent events of simple random ordering of letters. And I'll cut to the chase here, but this searching in this particular document, we're going to actually find 6 results. In fact, you can see that there's the 6 results right there. But I'm going to go back, and we're going to do a search from the received text. All right, here's the 6 results. So our math said we would probably find 5. Well, we actually found 6. That's great. And here they are. But that's totally to be expected, just treating this as a random sequence of letters. You scramble them all up, there's a likelihood that you're going to find, the first letter, second letter, and all ordered in that sequence. And our math totally ties in with it to exactly what we found. So nothing strange going on here. Don't create a story out of Travis with this, because it was expected just based on random statistics. If this was War and Peace, you'd find the same results. And what's interesting, the received text, I just switched source documents. I do the same search here. It's going to find different results. But those results are going to closely match the math as well. Okay? Now, the point of this is that when something is truly phenomenal, it will stand out. And when the statistics show that you really shouldn't find a particular name or a search term in these texts, then you might want to look at that. And when we get into the next video, we'll show how the Timotheus Key is really strange in that it actually shows up in any of these documents. And then as you add the probabilities of all these other things, such as the biological data of the author, it's very, very odd. We cannot explain it. All right, so this thing is searching. We've already found 5, which we would expect. Nothing special. We should get something around 5. I'll also lead you a cut to the chase here a little bit, because I'm not going to do the last search, and that's on the Leningrad Codex. But I can tell you, when I search the Leningrad Codex on this name Travis, it finds 4. This particular search, if I recall, finds 5. And it's interesting because the average of all those searches is exactly what the math said it would be. 5. And that's just expected. All right, so here we are. We've already found 5. We're almost finished. And this one is really funny because it exactly matched what our math said it would find, based on random ordering of letters. And there you go. There's 5, and they're totally different, right? It's just you've mixed up a bunch of letters. So And what we say in the user's manual, if you're Travis and you think you're special and, there's something amazing in here, well, think twice, Travis. So, anyways, hope that helps. That's the first part of this video, because we'll look at the Timotheus Key and some of those probabilities. And I believe the publisher is going to do the same, because they, they're going to counter what we might find here. And again, thanks for the emails, folks, because that helped guide us in doing this video. And as a reminder, we're all in this together, and I point out it's both sides of the debate. Okay, until next time, Godspeed from your chief geek at Ancient Text Research.